What if I told you that just 30 days of eating nothing but junk food could measurably change your brain, your liver, your hormones, and your metabolism, even if you feel completely fine? By the end of this video, you'll understand the most important part: whether these changes are permanent or if your body can recover once you stop. Let's start with the first bite. From the very first bite, something shifts. Before the calories, before the weight gain, before the cravings. Inside your bloodstream, a metabolic alarm goes off, because junk food isn't just unhealthy food. It's a very specific biological cocktail: high refined sugar, refined flour stripped of fiber, industrial seed oils, hyper-palatable salt levels, artificial flavor enhancers designed to override natural satiety signals. This isn't food designed to nourish. It's food engineered to stimulate. And the moment it enters your mouth, digestion doesn't even wait for the stomach. Salivary amylase starts breaking down refined carbohydrates immediately. Glucose begins forming before you even swallow. Within minutes, your blood sugar begins to rise. But here's the key difference. When you eat whole food, like potatoes, fruit, rice, vegetables, fiber slows absorption. When you eat junk food, white bread, fries, soda, candy, there is almost no barrier. Glucose floods your bloodstream, and your pancreas reacts instantly. It releases insulin, not gently, aggressively. Because biologically, high blood sugar is dangerous. It damages blood vessels. It creates oxidative stress. It glycosylates proteins. Your body treats it like a threat. So insulin spikes. And that spike does three things. It shuttles glucose into muscle and liver cells. It blocks fat burning. It signals the body to store excess energy as fat. This happens within the first hour. But something else happens too. Dopamine rises. Highly processed junk food activates the brain's reward center, the nucleus accumbens, in a way that closely resembles addictive substances. The combination of sugar plus fat plus salt doesn't just taste good. It overstimulates your survival circuitry. Your brain interprets it as, this is rare, this is valuable, eat more. Even though in modern life, it's unlimited. So on day one, you don't feel sick. You feel good. You feel energized. Maybe even euphoric. But beneath that feeling, the metabolic groundwork has already started shifting. Your insulin baseline begins rising. Inflammatory markers subtly increase. And your gut microbiome just received a very different message. Because the bacteria in your gut depend on fiber. And today, they got almost none. By day 3, your body is adjusting. But not in a good way. Instead of stable blood sugar patterns, you now live on spikes and crashes. Here's what happens. You eat cereal or donuts for breakfast. Blood sugar surges. Insulin spikes. Within 90 minutes, glucose drops rapidly. But insulin stays elevated slightly longer. Result? You crash. You feel tired, irritable, foggy, hungry again. Not because you need energy, but because your blood sugar dipped too fast. This is called reactive hypoglycemia, and it's extremely common with high glycemic diets. So what do? You reach for more junk food, another spike, another crash, and slowly your cells start becoming less responsive to insulin. This is the beginning of insulin resistance. It doesn't mean you're diabetic. But it means your cells are starting to say, there's too much insulin, we're closing the door. So the pancreas compensates. It produces more insulin. Now you have higher insulin, higher glucose fluctuations, higher fat storage signaling, and lower metabolic flexibility. At the same time, your hunger hormones begin shifting. Ghrelin, the hunger hormone, rises more often. Leptin, the satiety hormone, becomes less effective. Highly processed foods don't trigger fullness properly because low fiber, low protein, easy digestion, hyperpalatability overrides natural stopping cues. So by day 3, something subtle happens. You feel hungrier, than before you started. Even though you're eating more calories, your body isn't being nourished, it's being stimulated, and that difference matters. Meanwhile, in your gut, beneficial bacteria that thrive on fiber begin decreasing. Species that thrive on sugar and fat begin increasing. This alters gut permeability, which may increase low-grade systemic inflammation. You don't feel inflammation directly, but you might notice slight bloating, irregular digestion, lower energy, mild mood swings. And here's why mood shifts. Your gut produces a significant portion of serotonin, and gut microbiome imbalance affects neurotransmitter regulation. So yes, junk food can subtly influence your mental state in just days. But the real changes start during week 1. By the end of week 1, you probably notice something. You feel heavier, not necessarily fatter yet, but puffier, slightly bloated, less sharp. Here's what's happening beneath the surface. When you consistently eat junk food, especially ultra-processed food high in refined carbohydrates and industrial seed oils, your body experiences repeated glucose spikes. And every spike produces oxidative stress. Oxidative stress is essentially cellular friction. It damages proteins, it damages blood vessel lining, it increases inflammatory signaling. Your immune system responds. C-reactive protein may begin to rise. Inflammatory cytokines increase. Endothelial function slightly declines. This isn't dramatic, it's subtle, but inflammation is cumulative. And junk food is uniquely inflammatory because it combines refined sugar, refined flour, omega-6 heavy processed oils, additives and emulsifiers, especially emulsifiers. Certain food additives have been shown to disrupt gut lining integrity. When the gut barrier becomes slightly more permeable, sometimes called leaky gut, bacterial fragments like lipopolysaccharides can enter the bloodstream. Your immune system sees that as invasion, so it increases inflammatory signaling. Again, you don't feel this as inflammation. You feel it as low energy, brain fog, slight mood instability, poor sleep. Speaking of sleep, high sugar diets disrupt sleep architecture. Blood sugar crashes during the night can trigger micro-awakenings. Insulin spikes suppress growth hormone release, and higher inflammation interferes with deep sleep cycles. So by the end of week 1, something important changes. Recovery declines. You may feel more tired even if you sleep the same number of hours. But the most important shift is metabolic. Your baseline insulin is now higher than it was on day 1, and that changes everything. Because insulin doesn't just control blood sugar, it controls fat burning. High insulin equals fat storage mode. Low insulin equals fat burning mode. If insulin remains elevated throughout the day, your body spends less time burning stored fat. Even if calories aren't dramatically higher. But calories are usually higher, because junk food is calorie dense and easy to overconsume. So by week 1, you may already have gained 1 to 2 kilograms, mostly water and glycogen initially, because carbohydrates stored in muscles bind water. For every gram of glycogen, you store about 3 grams of water. This is why people feel puffy quickly. But the real shift begins in week 2. Now your body adapts, and adaptation is powerful. When repeatedly exposed to high glucose and high insulin, your cells reduce insulin sensitivity. This is early insulin resistance. Not disease yet, but the trajectory is clear. To keep blood sugar stable, your pancreas must now produce even more insulin. Higher insulin has consequences. First, it suppresses lipolysis, the breakdown of stored fat. Second, it increases de novo lipogenesis, the creation of new fat from carbohydrates, especially in the liver. This is how fatty liver begins. When excess glucose cannot be stored as glycogen anymore, the liver converts it into triglycerides. Some are exported, some accumulate. Non-alcoholic fatty liver disease can begin surprisingly fast under high sugar conditions. And junk food often contains both, High sugar, high fat, that combination is metabolically stressful because glucose and fat compete for oxidation. And when both are elevated, fat is more likely stored. Meanwhile, visceral fat begins to increase. This is the dangerous fat around organs. Unlike subcutaneous fat, visceral fat is hormonally active. It releases inflammatory cytokines. It increases insulin resistance further. It disrupts hormonal signaling. And it changes appetite regulation. By week 2, cravings intensify. Why? Because dopamine receptors begin downregulating. Highly stimulating food repeatedly floods the reward system. So the brain reduces sensitivity. Now you need more stimulation to feel the same satisfaction. More sugar, more salt, more processed food. At the same time, natural foods begin tasting bland. This is a critical shift. Your taste sensitivity changes. Whole foods no longer provide the same reward response. And something psychological happens. You start justifying it. It's only temporary. I'll reset later. It's not that bad. But physiologically, your metabolic flexibility is decreasing. Metabolic flexibility is your ability to switch between burning carbohydrates and fat efficiently. After 2 weeks of junk food dominance, your body becomes carb dependent. When glucose drops, you feel worse than before because your fat-burning machinery isn't being used regularly. Mitochondrial efficiency may even decline slightly, which means energy production becomes less stable. And now we enter week 3. This is where hormones start shifting more noticeably. By week 3, this is no longer just about calories. It's about hormonal signaling. Let's start with cortisol. Frequent blood sugar instability increases stress signaling. Cortisol rises to help stabilize glucose. Chronic elevated cortisol promotes abdominal fat storage, muscle breakdown, sleep disruption. Next, testosterone. High insulin and increased body fat can reduce testosterone levels in men. Because fat tissue converts testosterone into estrogen through aromatase. In women, insulin resistance can disrupt ovarian signaling, which may influence menstrual regularity. Then there's thyroid function. Very high processed diets low in micronutrients may impair optimal thyroid hormone conversion. Not dramatically in 3 weeks, but subtly, because junk food is calorie-rich but nutrient-poor. Low magnesium, low potassium, low omega-3, low antioxidants. Your body needs micronutrients to regulate metabolism. Without them, systems become less efficient. And then there's hunger signaling. Leptin resistance may begin increasing, which means your brain no longer accurately senses energy sufficiency. You eat more, feel less satisfied, and store more. Meanwhile, muscle protein synthesis declines slightly if protein intake is low. Many junk food heavy diets are surprisingly protein deficient. So even if weight increases, body composition worsens. More fat, less muscle proportionally, and this lowers metabolic rate further, because muscle is metabolically active tissue. By week 3, you may notice lower motivation, reduced gym performance, more fatigue, increased belly softness, skin changes, more oiliness or breakouts. Why skin? Because high insulin increases IGF-1 signaling, which stimulates sebaceous glands and increases acne risk. This is now a systemic shift. And then comes day 30. This is where patterns consolidate. 30 days. That's not a lifetime. It's not even that long. But biologically, 30 days of consistent input is enough to shift your baseline. Not temporarily, but measurably. By day 30 of eating only junk food, your body is no longer reacting. It has adapted. And adaptation cuts both ways. Your fasting insulin is likely higher than it was at the start. Your average blood glucose may be slightly elevated. Your pancreas is working harder. Your liver is storing more fat. Your visceral fat has increased. And here's the important part. You might not feel sick. That's what makes it dangerous. Metabolic dysfunction doesn't begin with dramatic symptoms. It begins silently. Let's break down what likely changed. First, body composition. Even if total weight gain was moderate, body fat percentage likely increased disproportionately because high insulin favors fat storage over muscle preservation. And if protein intake was low, muscle protein synthesis declined. Less muscle means lower resting metabolic rate. So now, even at the same calorie intake, you burn fewer calories than before. Second, metabolic flexibility. Your body is now more carb dependent. When glucose drops, you feel irritable faster, hungrier faster, more fatigued, because fat oxidation pathways were suppressed for 30 days. It's not permanent, but they're down-regulated. Third, inflammation. Low-grade systemic inflammation is higher. Visceral fat contributes to inflammatory signaling. Gut barrier integrity may be reduced, and repeated glucose spikes increase oxidative stress load. Fourth, dopamine sensitivity. The reward system adapted. Natural foods feel less stimulating. You crave hyper-palatable combinations. This is neuroadaptation, and it's reversible, but not instantly. Fifth, lipid profile changes. Triglycerides likely increased. HDL may have decreased. LDL particle number may have shifted towards smaller, denser particles. Again, not catastrophic in 30 days for a healthy person, but directionally negative. And direction matters, because biology compounds. If 30 days shifts you this far, what happens in 90 or 5 years? Now we move from adaptation to progression. If this junk food pattern continues for 3 to 6 months, several processes accelerate. Insulin resistance deepens. The pancreas continues compensating. But beta cells are not infinite. Chronic overstimulation eventually leads to dysfunction. Fatty liver progresses. Triglyceride accumulation in the liver increases. Hepatic insulin resistance worsens, which increases fasting glucose further. Visceral fat expands. And visceral fat is metabolically active. It secretes inflammatory cytokines like TNF-alpha and IL-6. These worsen systemic insulin resistance. This becomes a feedback loop. High insulin leads to more fat storage, leads to more inflammation, leads to more insulin resistance, leads to higher insulin. Now, cortisol begins staying chronically elevated. Sleep worsens. Recovery declines further. And then something important happens in the brain. Chronic high-sugar diets reduce hippocampal plasticity. Animal studies consistently show that high-sugar, high-fat diets impair memory performance. Neuroinflammation increases. BDNF, brain-derived neurotrophic factor, may decrease. That affects learning and mood regulation. You might notice lower motivation, more mood swings, less mental clarity, reduced discipline, and then cardiovascular risk begins rising measurably. Endothelial dysfunction increases. Blood pressure may trend upward. Triglycerides rise. HDL falls. The process that leads to atherosclerosis begins early, long before symptoms. And yet, most people still feel okay. That's the trap. Chronic disease doesn't begin with pain. It begins with silent shifts in baseline. Now the most important question. Is this damage permanent? No. Not after 30 days. The human body is incredibly adaptive and incredibly forgiving. If you switch back to whole foods,